All right, so we're going to take a look at 1.8, which talks about inverse functions. So the objectives here are to verify inverse functions, find the inverse of a function, then use the horizontal line test to determine if a function will have an inverse. Use a graph of a one-to-one function to graph its inverse function, and find the inverse of a function and graph both functions on the set of the same axes. So first, let's talk about the definition. So this comes from the book. This is how it's written in the book, and so we just want to read through it, and then we'll explain how this works. So it says, let f and g be two functions such that when you do the composition, f of g of x, you're going to get x. And then if you do the reverse composition, you're going to get x again. If that's the case, the function g is the inverse of the function f and is denoted by f inverse. So f with this exponent of -1. So it's not an exponent of -1. It's the way to read or how to denote, I should say, the inverse function. So if you compose a function and its inverse, you're going to end up with x every time. And then if you compose it in the reverse, you're going to end up with x. The domain of f is equal to the range of f inverse and vice versa. So that last sentence is telling us the domain and range are swapped on inverse functions. So we'll start by verifying we have an inverse. So we're going to verify it using the definition on the previous page. So we want to check, is this, if I do that, compose f composite g of x, do I get x? And I need to check, is this, is the reverse f or g composite f of x, keep writing the wrong thing here, sorry, f of x, is that also equal to x? So we want to check it both ways. So we'll start with this one. And we're going to say f of g of x. And so here is g of x. I'm going to put it in place here. So g of x is the expression x plus 7 over 4. So that's going to be my input into f. So f of x and input x plus 7 over 4. So my function f is 4 times the input minus 7. It's right here. But now my input is g of x, which is x plus 7 over 4. And now I'm going to simplify this. 4 times this. The 4's will divide out. I'll be left with x plus 7 minus 7. Then 7 minus 7 is 0, so I end up with x. So I got x when I did the composition. So far, this is true. Now I have to check the reverse and see if it fits that definition. The reverse said to check g composite f of x. So function g is now on the outside, f of x is on the inside. So 4x minus 7 is going to go into function g as the input. So it'll be g at this. So g is x plus 7, the whole thing divided by 4. So I'm going to input 4x minus 7. So in the numerator, I will end up with 4x minus 7 plus 7 divided by 4. I'll get the negative 7 plus 7 is 0. So I'll end up with this. 4 divided by 4 is 1. So I'm left with 1x or just x. So this shows that that part's true. So this works, that's true. So then I can make the statement that since f of g of x is equal to the same thing that g of f of x is, which is x, that verifies that f and g, function f and function g, are indeed inverses. So how do you, if here we're just verifying, but what about if you were just given f of x and it said find the inverse? How do I do that? How do I find what this g of x is? You can do that by following the steps on the next page. So this page is entitled Find the Inverse of a Function. And in order to find the inverse, we're going to first start by doing step 1, which is to replace this function notation f of x with y. Step 2, interchange the symbols x and y. So interchange the variables. Wherever you have a y, put x. Wherever you have an x, put y. And then I'm going to solve for y. If at this point the equation does not define y as a function of x, then the function f does not have an inverse function and the procedure ends. If it does define y as a function of x, then the function has an inverse function. And the last step would be is if you have an inverse function, replace the y in step 3 with this function notation. Then you can verify that you did the solving of this and finding the inverse properly if you do the composite, the one way and then the reverse way, and see if you get x. So what we did in the first part here. If after you get them, then you can do this and verify you get x and x, then those are inverses. So we start with this one. And I'm going to follow the 4 steps on the previous page. So I want to find the inverse of this function. So the first step is to replace this f of x with y. So that's my first step. And here I'll put it in a different color so you can see what I did. I replaced the y, the f of x with y. Step 2. Step 2, I'm going to interchange the x and the y. So I'm going to take wherever I have a y, I'm going to put x. Wherever I have an x, I'm going to put y. So interchange. So this was, I'm just going to write out what I did. Replace this notation with y. Then interchange x and y. And then step 3 would be to solve for y. So step 3, now that I have this, I want to solve for y. So that means I want to get y by itself. So I'm going to first subtract 7 from both sides. I end up with x minus 7 is equal to 2y. And then I'm going to divide both sides by 2. And I have to divide this whole thing by 2. Don't just write it x over 2 or 7 over 2. It's the whole thing on the left side divided by 2. The 2's divide out here. I've got y is equal to x minus 7 over 2. Here is my inverse. Step 4 is to now take and replace the y, and I'm swapping the 2 sides. It doesn't matter which way you write it, but we're used to seeing the inverse notation on the left side, so I'll swap the 2 sides. And so in this step, I am replacing the y with that inverse notation. So this right here is the inverse of this. Now, We can verify it by doing the composition. So if you took F composite inverse, you should get X. And if you did the reverse, inverse F composite F of X, you will also get X. We can also take a look at the graph. So let's do that. So you should grab your calculator and follow along with me. So when I want to graph something on my calculator, I'm going to hit y equals. And in for y1, I'm going to put the original function f. And in for y2, I'm going to now put the inverse I came up with. Remember, whenever you're writing an expression in the numerator or denominator, that it has an expression. So it's not just one digit or one number, one constant, or one variable, but it's an expression. You want to surround that expression with parentheses. Here are my two. When I graph this, you're going to notice that the two lines will be mirror images about the identity function. What is the identity function? The identity function is y is equal to x. Y equals x is the identity function. So it's this black line here. So if you were to imagine folding your paper calculator screen on the identity function, the two images would be mirrored. And just like I mentioned before, the calculator screen is not a rectangle, it's rectangular. So if we square it off by hitting zoom, I think it's, did I do zoom 6? It's zoom 5, sorry. Zoom 5, you can see it more clearly that it does match up pretty well. So those are inverses of each other. The blue is the original function and the red is the inverse function. You can also, and we'll talk about this more in probably the next video, the domain and ranges are swapped here. If you were to look at the table, second graph, and let's imagine, oh, first let me get rid of this third line. If you were to look at the table, now just cover up this portion, cover up the Y2. This is 0719211. If you were to swap those numbers, you will see 70 is on the inverse. 91 is on the inverse. 11.2, if I go down, 11.2, the inverse function is in red here. So you take the domain and the range and you swap them. 313, there should be 13.3. Yep. So all of the x's show up as the y in the inverse, and all of the y's show up as the x in the inverse. The domain and ranges are swapped. Continuing on to the next page, this says that the horizontal line test for inverse functions. A function has an inverse that is a function if there is no horizontal line that intersects the graph of the function f at more than one point. So when we take a look at these, the first thing we have to make sure is that is it a function? So it has to pass that vertical line test in the first place. These tell you that the graphs represent functions, so they've already passed the vertical line test. But do they have inverses is only if they pass the horizontal line test. So in order to have an inverse, it has to pass the horizontal line test. So graph A does not pass the horizontal line test. The horizontal line crosses the function in two spots. So we're going to say it does not have an inverse. In section B here, this one does pass, because if you were to draw horizontal lines anywhere along this function, so this has an inverse because it passes the horizontal line